All right, so welcome to our talk. Today we're going to talk about our open source working group, WG Component Standard. I'm Mike Taufen from Google, and this is Leigh Capili from Weaveworks.
Yeah. Hi.
So today we're going to start out with just a little bit of history of kind of some of the problems we were solving last year and how this working group got started. And then we'll talk a little bit about our working group today, some of our current projects, contributors, some of our mentorship efforts, and also how you all can get involved.
So just like the bit of the history component, we're going to just make sure we hit the basics so that we're not assuming anything. The Kubernetes style API, it looks a little bit verbose, and you might be used to seeing these things, especially by the end of this conference. And maybe all of that looks a little bit much, but when we have these things in a YAML file, we've got a Kubernetes object. It's got some really nice properties that we can use that really are the foundation for all of our tooling and the way that Kubernetes enables an entire ecosystem of tools to be built. So what does API machinery really mean? There's a core portion of this, and the first key idea is that when we have API machinery, we get versions. We get schema that's versioned. Right? And so we have this version of the API, this version of the API, this version of the API. And there's three components to this that Kubernetes calls the GVK. You might see this in the code. It stands for group, version, kind. Right? And that three-section component right there is represented in this API version kind field that you see on everything. I know definitely that when I first started using Kubernetes, I was a bit tired of writing this over and over again. But when you've specified the API version, this gets you several guarantees. Right? So right here we see the group is apps, and then the version's v1, the kind is deployment. And the things that we get when we specify this GVK are that we now have a stable platform to ensure behavior when things are asking us about operating on a specific GVK. This means that something like the API server can serve multiple versions of the API at the same time. We have a version deprecation policy that you can read about in the community repo, I believe is where that doc's. Yep. And then now as a user or as somebody who's building a system, you can write config such as a v1 deployment. And for as long as the API server continues to support that config, even when there's a v2 or a v2 alpha 1, that you know that that config is going to work the same way. So your config is good. And it's also supported by multiple tools. We have Helm, we have kubectl, Kustomize. Multiple different tools that can use these APIs to basically read, write, parse them, and build on that common layer. And then now users have an upgrade path. Also lets you do things like conversions and some of these more advanced things, validation. API machinery serves us in many ways that we take for granted, but are core to the project.
So that all sounds great. Most of you are probably familiar with that from working with Kubernetes. So like, what's actually the problem? Like, we use these YAMLs every day. They mostly get the job done. That's great. So first, let's take a step back. If you've used a Unix-style computer system in the past, you're probably familiar with the command line. You've got these sort of commands, which are programs installed on the system, and most of them take flags that describe some kind of configuration. So here's a simple example. Do something, foo is 1 and bar is 2, 3, 4, 5. And these values are just arbitrary strings parsed by the program, and that's fine and convenient for most tools and small programs.
Yeah. Even the flags. Flags are arbitrary strings too.
Yeah, right. So, but what about Kubernetes? We've got all these components. A lot of things get a lot more complicated. Are flags still sufficient? Because today, even though all the things in your cluster are configured with these nice YAMLs, all of the components running the cluster itself are still configured with command line flags. So if you've ever configured a Kubernetes cluster from scratch, you've probably seen something like this, which is a little bit harder to work with. It's hard to read, it's hard to write. What are you going to do when things get this complicated? Well, first let's talk about some of the problems with this. Right? Number one, these command lines that all the Kubernetes components provide are actually public APIs. However, they're not versioned independently from your Kubernetes version. And if you have paid attention to Kubernetes versioning in the past, you'll know that we use semantic versioning. And every release, we increment the minor version, which suggests that everything should just continue to work and there should just be some new features. However, all of the APIs in the API server are versioned independently from that. And over there, breaking changes are communicated in those versions. What do we do for command lines? Well, actually, we just have a policy that says, if you pay attention to our release notes, and if you pay attention to warnings in your logs, we'll tell you when things are going to break, and you should just make sure you pay attention to that. So there's actually nothing in the overall Kubernetes version that expresses breaking changes in admin-facing component command lines.
Yeah, like a single component doesn't serve multiple versions of flags.
Right. So,
right. Yeah.
So that's problem number one. Problem number two is that tools can't understand these. All of these sort of custom special structures that are embedded in these arbitrary strings in the command line are only known to the component that's parsing them, and the libraries that do that aren't available anywhere for anyone to consume. So if someone says, could you write something that can generate a command line config for the kubelet? You have to go into the code, figure out what it's doing, try and replicate it, and hope it doesn't change. The same thing is kind of true on the internal implementation side. It's a problem because every time you invent another structure in there, say you invent a new kind of list that's separated with a different separator, or you wanted to use less than or greater than signs in some kind of map type structure because it looked better for resource constraints, people are writing more and more custom parsers inside these components. And that both invites a lot of bugs and adds a lot of complexity that could be removed if we just express these structures with the basic lists and maps that YAML already provides. So what's the solution to this? Well, it's something that we in the community have started to call ComponentConfig. That's kind of the term of art for it. And all it is use Kubernetes-style APIs to configure components too. People like them because they're readable and writable. They're what we're used to in Kubernetes. They have clear stability policies that are expressed in the same way as all the other Kubernetes APIs that people are used to working with via the API server. And tools like them because YAML is a common format with wide support. The API version and kind and other API machinery characteristics in Kubernetes are supported by a lot of Kubernetes-centric tools like Kustomize and Helm. And so by avoiding all these sort of non-standard structures in command lines, we stop preventing interoperation and start enabling it. So these version schemas really help everyone. And so what's actually our progress so far in doing this? Well, about a year ago, I was working on it a lot. And so we managed to get the kubelet to a v1 beta 1 API for component config. We had a few other groups in the community pick up the idea and start to implement it in components like kubeproxy and kubescheduler. And so those are currently sitting at v1 alpha 1. kubeadm was really enthusiastic about it and is actually totally driven by component config Kubernetes-style APIs today. And it can generate the configs for the other components. But that said, we have this large in-progress migration that's taking place across multiple releases. Many of the components in Kubernetes have hundreds of options. And so it just takes a lot of time to kind of argue about what should the structure of this thing be when we transform it into YAML. Should we, because we're actually inventing a new version, should we change some defaults and make it more secure? And all of those things make this kind of migration take time. So as I moved on to other projects inside of Google, other people working on it, maybe they started university or they wanted to focus more on their families. It gets harder and harder to find time to work on this. So what we've realized is rather than just putting more pressure on people who are already working on it to get work done when they can't, we actually need to start bringing more and more people in to our working group and into the community to work on these things and create more sustainable leaders. So that was a big reason that we started Working Group Component Standard, was to further this component config work. And then we realized that there are some other areas with a lot of refactoring and standardization that are needed in the project. So we didn't just make it Working Group Component Config, we made it Working Group Component Standard. And we're really excited about it is we've recently started to get a lot more contributors in looking to help out. And so we're looking forward to 2020 making a lot more progress.
Yeah.
So I'm going to turn it back to Leigh to talk a little more about the working group.
Sometimes people ask us, okay, well, what does component standard do? Right? And we've talked a little bit about that, but how do you concisely explain to somebody what the value of an infrastructure portion of the project has to Kubernetes on users and vendors, folks who are relying on this platform? And we say that when you want something to work the same way across Kubernetes components, then you should come here. And to get a little bit more to our mission statement, we want to develop a standard philosophy, a standard set of libraries, a standard approach that's cohesive across all of the Kubernetes components. So as we build and maintain the project, that it just works, right? And if you have a CVE and you have to patch the vulnerability in a single component, it becomes much more difficult than if authentication is in a central place. So some of those areas beyond what ComponentConfig has already been discussed by Mike, the flags and the APIs associated with that, the generation, the tooling, the linting and testing. There's things like status endpoints, right? So how do you know that the API server is configured correctly? Right? And if you're running a security conformance tool, then how does it know that? It shouldn't have to parse command line in order to figure out they're using the right options. Right? And it probably gets that from the process table. So, the integration points like the delegated authentication authorization, if you want to plug that into something that you run on top of Kubernetes, that should definitely be standard. It's a security surface. And then instrumentation, the logging and metrics of the project, which are important for understanding how it performs, debugging in production. And instrumentation is observability for the project, and it's a pretty key point. All the details about how some of the details about how some of these things should be implemented, some of the context where they are non-conformant with each other, is available starting in KEP 32 and onward. So.
All right, cool. So we have a bunch of different projects in those areas that Leigh just talked about. A major focus right now is continuing these flag to config migrations. We have people working on Kubelet, Kube Proxy, Kube Scheduler, and the controller managers right now. We have also been doing some work around strict decoding. What that means is, in the past, if you wrote this configuration file, handed it over to your component, and you made a typo in one of the field names, that field would just be ignored and set to the default value. After some recent changes that have merged, you actually get an error message for typoing that field. Mm-hmm. So that's a big improvement in usability. We've got some improved testing coming in. We're doing some cleanup in some of the flag backwards compatibility layers that we implemented with the original migration. Again, we're standardizing and breaking out some of these common server endpoints. We have someone new to the working group who's working on a structured logging solution across the project, and it's actually been really fun at KubeCon. We've had more and more people come to us and say, hey, I want to help with like improving this other endpoint, or there's this other area like with TLS that I think could be more standard across the project. Like, can I help you guys out doing that? And it's been really cool being here at KubeCon. We've gotten a lot of interest.
Yeah.
So one of the other things that we started doing back in September, as we kind of realized that our time was getting thinner in terms of being able to focus on the technical stuff, was that we need to start creating more sustainable leadership in our community and especially in our working group. So we sent out an offer for direct mentorship for folks who are interested and a list of projects, and we've got 15 people who are now working on key projects in our working group's mentorship group. Some of whom we've actually gotten to meet at KubeCon, so that's been a lot of fun.
It's been really cool.
You'll see these people around the community more and more. They're doing more and more to help out. Some are ramping up. Some have sent some PRs already, and that's actually what the next slide's about.
Yeah, we're hugely grateful for the time that people are taking, to move Kubernetes forward. So Kelsey's keynote really struck a chord with me, right? We all get together with each other and we're drafting along to push this project, and folks have differing constraints and different things that they're looking to accomplish. Some people, primed to be leaders and the future leaders of the project, and other folks have that 5 minutes, other folks have that 3 hours a week. And it's been really exciting to meet people and see the pick up projects and accomplish things. And so some of these areas that we've talked about in the past about 6 months, we've started shipping patches. There's a core implementation portion of this component config, the strict serializer thing that Mike talked about with the usability of configs dropping unknown fields. I wrote a core implementation portion of that just in the runtime libraries, and then we left it there for a little bit. And then some new contributors got interested, and we went into deep dives in the code. We got on video calls, we got to know each other. And then they went off and ran, and they published design docs, and they commented on KEPs, and they pushed these patches up. And now we have this thing called the lenient path decoding, which is an upgrade that's shipping in 1.17 that provides warnings for the strict decoder specifically when using configz on the same API group. And then with a new API group, if a person opts in, those things become errors. Very sophisticated API machinery behavior that's been implemented by people who are brand new to the project, essentially, working together really with just guidance and reviews from us. Building that kind of knowledge, duplicating it in the project, is something that is pretty unprecedented in a formal way, and we're excited to be welcoming new contributors to really a critical, important future area of really keeping the project maintainable, cohesive for the next decades that we have in front of us, shipping and improving and running Kubernetes. And, things are, in some places, they're in a bad place. we have things to improve.
A lot of things work well in production, but when you look under the covers, there's still room for improvement in terms of maintainability and the sustainability of the project. And so that's one of the big things that our working group is focused on.
Yeah, and then kind of the meta task, right, is that there's a huge wall. Using Kubernetes, lots of resources, developing Kubernetes, especially when you get into the guts, helping people build a proficiency and then building the documentation, the community that allows people to continue like having ownership of the core is a really exciting thing that's happening in this working group. There's other things that are happening. We have an open core implementation library for the testing and conformance of ComponentConfig APIs, making sure that it's not easy, to assemble things with API machinery. So how do we ensure that they stay correct and that things are uniform across all of these components? We could do that with a test suite, and that the exceptions will now be built into the code so that we know where things are not conformant, right? And then also, there's this area of flag and config handling with components. And historically in the project, we've had some complex logic, such as in the kubelet, to make sure that flags could override ComponentConfig APIs as a backwards compatibility layer so that people can continue operating the kubelet in the way that was necessary, but then moving towards this component config. And other components saw that and either chose or did not choose to implement it for various complexity reasons, as well as the constraints of maintaining the project. And so Mike published this legacy flag prototype library, which is merged in Kubernetes segs. And then we have another contributor that has this kubeproxy prototype, which is open for reviews on how we can get legacy flag perhaps working as a uniform way to do overrides as we support the backwards compatible interface of flags for operators. So, how you can get involved. Obviously, we've got a couple work streams, and then there's folks who are working with the project that you can reach out to. But then we've got normal Kubernetes governance, which means that we have an open meeting that's available on the public, and it's recorded to YouTube so that you can asynchronously consume the meeting notes, which are in a Google Doc format, and then the actual video and audio on YouTube. And then we have the mailing list. There's also an office hours. Office hours is great because you can just jump on and hang out with us.
This is actually one of the things that's come out of our mentorship program. A lot of people were looking for a space where they could come and ask kind of questions and get more one-on-one in-person support. And so every Tuesday for an hour, we have an office hours where I'll sit in there or Leigh will sit in there on video for an hour, and anyone can drop in whenever it's convenient for them, ask questions. We do code deep dives. We do code reviews sometimes, kind of whatever people need to keep their progress moving.
The Google group is part of the permissions model, and if you join that, it's public. You just have to join it. Then you get the calendar invites, you get the messages from the Google group forum, and it also gives you edit permission to our meeting notes so that you can participate and schedule things that you want to talk about ahead of time. Our GitHub has the README that is kind of how you get all of this information if you were finding us online. And in the GitHub README, we have, it's inside of the community repo, Kubernetes community. We have links to the project board. We have information about all of this. We have a schedule for when the calls are held. So you can just go to that one place and get connected with all of this. And then we really need help with project management. So if you're watching this or you're here right now and you are a project manager and has experience like just helping keeping things organized, task management, if you only have a little bit of time and you can spend that little bit of time helping keep the project more organized, that would be super, super helpful. We'd be very grateful because the influx of work has just, it creates a project maintenance burden. And then if you're a developer, the important thing is to keep your eyes out for places where standardization needs to happen and bug fixes or refactors in the code need to occur. If an issue isn't open about the thing that you find, please open it with the issue label. If you're reading an issue even as a user and you're like, oh, that behavior seems kind of non-standard, or we should think about how to make that uniform, then we're able to add that to our project management triage with just labeling WG component standards, so please do that. And then lastly, in addition to Mike and I, there's also Stefan Szymanski from Red Hat, who helps chair the project. And then on Slack, we have 2 Slack channels. The first being the main group general chat, and then also the specific mentorship program chat, which is a better place to, if you feel a little bit uncomfortable, it's a comfortable place to ask beginner questions, request one-on-one time, schedule problem solving with your peers, post, things that are, it's just a little bit more dedicated, that space for the mentorship. And yeah, please come join the call, get involved with us, let us know what your goals are. We can figure out how to get there, and ping us on Slack.
Yeah, we'd be happy to have you, and we'll help you get involved. So thank you. And now we can take questions. If anyone has questions.
Yeah. Great. I can run a mic.
All right, we'll run you the mic.
Yeah, here we go.
So
I will run. All right. Your name's Chris?
Chris, yeah.
Yeah.
So I use the kubelet configuration in a project where I generate that config, and I was wondering, so the internal library has some defaulting stuff that's not in the external one, and I'm trying to only use the the
external version?
of the
Kubelet
the non Kubernetes repo one, just so that
Yeah,
Repo
the
version.
external versus the internal version of the ComponentConfig API.
And there was a note in there, I think it said something it's not, some of the parts weren't, how the CI tool or whatever that pushes everything around, it wasn't put there. I was wondering if there was a reason for that. I ended up copying some of the default, there's a default
The defaulting
setting function.
functions, yes.
Yeah, so I was just wondering if that was, something that was done for a reason, or if it could.
It is intentional. Mike, do you want to?
I think that a lot of that is just down to convention of how other pieces have published their APIs in staging repos. So I think that's something we can revisit in the future, and that has come up a few times in meetings. Another thing that's come up is finding ways to export conversion functionality between versions. Having that internal type be private makes it really hard for tools to consume a library that lets them do the conversion on behalf of a user. So those are definitely active discussions.
The reason why the internal library is private is because it's an implementation detail of the API machinery. So we can add things in there and change it without having any kind of guarantee or parity with the external type, which is the important interface. But yes, the defaulting and conversion logic is one of the important things for ComponentConfig UX. And so we're actually really interested in, we said earlier, basically we need a KEP for this because we need to expose some sensible interface. There's a couple approaches that people have talked about.
Yeah, so a few people this week have kind of offered to work in that area, so hopefully we'll get a little bit more there soon.
Yeah. If you want to help us write a KEP, we can definitely do that. And, cool. Does that answer your question, Chris?
Yeah,
Cool.
Thank you.
We can chat later too. Sweet. Any other questions? Cool. Thanks,
Thanks, everyone.
Thank you so much.
Yay, KubeCon! We're done!